Assalamu alaikum friends. Today we will learn about shift registers in TIA Portal V16. First of all, we will open our TIA Portal and we will create new project and such as shift GIS shift registers. Any name you can give it here. Create, then create. And then open the project view first of all, or anywhere you can go in the and go to there, add new device. Which device you have in physical condition, you can choose it from here. CPU, I have CPU 1215 DC relay and that article number, that one version 4.4, and then click OK. It will take some time because of one first time we will make it configuration with the hardware. It will be use this procedure. If you have any other communication boards also you can use it here. You can add it here from this area. And now I have only this one, I have already, but I will use only. And next you have to go in program blocks and then click main OB. In main organization block, first of all we have to choose for using that shift registers, that commands, that which one here, that shift right. What he says, shift right means shift right any bit shifts the content of the operand at in input bit by bit to the right and outputs the results at the output. What he says, it means when you're giving the signal at this command, I will click it, double click and I use it here, and you have to use it here, that data register also, which you use. I use the byte, and here I have to be choose must be one signal, which signal you, from where you giving the signal to this data register. And here I will choose my first input I0.0 of my PLC, and this must be choose one pulse. If I give that direct from I0.0, the many of bits they have generate in this command, and here we will use any M50.0. I will choose my this internal relay for on condition, and first of all I will have to be data give it here, which in the byte this I have to be put data in that this register. I use MB10 for the use this register, and how much any registers you want to be move, that you have to be define it here. I will move it at 1. I want to only one bit I like to be moved, and this also I take in MB10. I don't need n because of I like to move this data in this MB10. And now how we can understand about this one, when I giving one pulse it here, it will be forward one pulse there. In MB10 in every byte, you know, when you are using the byte, in every byte have 8 bits, you know. And here we take one more command for to reset this function. One move command I will take. Oh no, sorry, go little back. And here first I have to take this branch, and after I can use this move command. And here also I will choose one input to make it reset I0.1, and this also I will take one pulse, and this I will use 40.0, and you can use no problem. And here I will use any data registers. MD10 I can use no problem. MD10 for write yani when I like to be go back yani when all bits move to write that bits, after I have to be go again in first yani. And here I will take MB10 because of I have to make it reset for MB10. So let's, in next condition we will use it here only in making the one row program. All what do you understand yani? This it here I will use my that MB10 I am using, that I start the first bit of my M10 M10.0, and here next I will take for yani I will take 4, 5, 6 or 7 to understand yani how to use M10.1 M10.1, and here one more I will take to choose one more, and here I will make one output, here I will make one more output, here one more output, and we will give the name at it here M10.2 M10.3 M10.5, and here I will choose Q0.5, here I use Q0.0, here I use Q0.1, Q0.1, and here I will choose Q0.2, here I will use Q0.3. separate after you better understand yani that yani when my M0 dot, that first bit when it's on of this MB10, first bit when on, after this Q0.0 will be on. When second on M10.1, after Q0.1 on. Same serial wise we will write. Have more yani up to Q7 bits yani 8 bits data, because we are using that byte 8 bits data here is using. Now what we do, let's first download this program to the PLC. it will be finding. Now first have to be start search, which is devices connected with our PC. That first have to be shown, and after now it's connected successfully, and then click it load. Now it's first of compiling the program, and now 0 and click it stop all and click it load. And then click finish. Now your program is successfully downloaded to the PLC, 0 error, 0 warning. And now you go to the make simulation. Oh sorry, this again I clicked, can make it cancel, and you go to the direct make it in simulation. Now for example, and 8-bit data, when you write it here in hexa, you put the condition 80 when you write, that will be first bit on. This data I will also put in decimal format so you better understand. Okay, also we will take one watch table because of you better understand. Force table. Here we will use make it smaller after you better understand. Address we will use it here MB10, and condition we use it in binary, and make it simulation on, and you can see it here your monitoring data. Now let's see, for example, that MB10 of the first bit, that same like you can use it here 1 2 3 4 and 4 5, and that one first bit is on of the that MB10. But when here is why not showing our any bit, because of we are using only up to M10.5. if 6-7 bits with number we used, after this is our on, internally this relay is on. But see, when we move this, as we give the signal at I0.0, that you can see that will be shifts in next next bit. M0.6 6 number, this is now on, and here also we will can see it here. When that last one is coming, M10.0, our that's relay Q0.0 have to be energized. Now this is Q0.3 number, 4 number, 5, 6, 7 and 0. See, when our first bit is on, M10.0 is on, our Q0.0 will be energized, because of we defined it here data yani first bit of this MB10 of this data registers, we have to be used first bit need to be on. This is going to yani right side yani, and as I give another signal, after our Q0.0 will be stopped. You can see here after one bit when I give it here, because it's moving to the right, if you go into the next bit when you using that another data registers here, after you can see it here. And now for to reset this data, I have to put it here 80 in hexa. When I put it 80, it will be reset this data. As I give the signal I0.1, it will be go at back yani at number 1 bit yani. Number 1 means Q0.7. I will explain more one more, but we will put no problem after you better understand how it works, this system. Let's shift, sorry, here we will take one branch and one more branch, and here we use one contact, here also use one more contact, 5, 6, and that's one 7. This will be lost. And here next we one relay use, here also one relay use, that we will give M10.6, and here we will give M10.7, because of in one byte have total 8 bits yani. And now here we give Q0.6, Q0.7, and again download to the PLC. Click it load. See, and make it this one online. See, this is our first bit, M10.7 of this byte of MB10 byte have first bit M1.7, M10.7 is on. After our Q0.0 is on. As I give the signal, it will be moving next. See, now our Q0.M10.6 on. Little I will go more up. So we will take it here. That, see now this is 6 number on. As I give that signal one more, it will be going 5 number. As I get one more signal, it will be going the next signal number 4. But we 4 we not is define it here because of this 4 not shown in the system. We 3 write and we go direct in 5. This is the mistake. And now one more, when I give the signal, that Q0.3 will be on. As I give one more signal, Q0.2 will be on. Yani means it's going from left to right. Yani next will be on. One more again signal will be going next. Yani now this is the last. As I going yani one more signal came, after this will be off because of it's go into the next condition in minus value. And the same as this, for example, we will choose this one. Stop the simulation. Stop the simulation. As here we can choose, and here you can go. This is first we're using shift right, and now we use this one shift left. Same data, this will be moving at here. First this is coming from 0 to 0.7 to 0.0 yani, and then now it's going from up to down yani, left to right yani. First it's going right to left, now it's going left to right to left, sorry. And make it this download inside the PLC, and then click load. Make it simulation on, and now see, now we're using this data in left to right. And first we write it here 80 means this is first bit yani 7 number bit. Now we write it here 1, for example, in hexa, so it will be choose our first bit yani, and for reset condition we also put it here 1. Okay, so we put it here in hexa condition, we will put it here 80. Here we put 1. This is first one yani. First it's going to from left to right, now it's going right to left yani. As I giving signal one more, it will be goes to next yani M10.1. As I give one more signal, it goes to second. Same yani, this will be serial wise, this data will be moved. See it here. As I give one more signal, it will be go in Q1 0.3. But now if I one more I signal give, it's going to Q0.4. But Q0.4 is not here. As I give one more signal, it will go to the Q0.5, Q0.6, Q0.7. As I give one more signal, it will be goes all closed. And as I give here 1, I need to 1, and as I give a one signal I0.1, it will be go back to 1. Now I hope you understand about this system, that shift registers, how we can use in the programs. This all look like you can think about yani this M10.0 or here you another signal also you can give I0.0. This you can think about, this maybe a sensor, maybe a in outside example means yani somewhere have we all feeling that in any company or any machine bottles filling for water or any juice or something. When you using this command, one conveyor for example is running at upside, that bottles are running, some small some big, and you can how to handle yani filling equally. One bottle is for example 250 ml and one bottle is for 500 ml. How you can connect fill the equal water or juice inside the bottle. So these areas you can use this very helpful, this command. You can use this command. Example means I0.0 is your first register, first signal for to fill the 500 ml bottle, and second one bottle maybe comes 250 ml. What you do, you have to put one another signal, another sensor which is I0.1 yani. When that signal 1 comes, after you can this come move, you can any other data register move, how much value you can up time, maybe timer you can use it in this command. And when it's coming next, again signal coming, after you have need any other value, you can move this value other yani. How much many this it will be helpful in this programs logic, you can use this one. Maybe for example this I0.M10.0 is your Q0.0 was solenoid valve for opening the water, and you can use it here one timer, how much time you like to on this command, and after this will be off. And when next signal coming, next maybe your bottle signal is coming 250 ml, and you can use timer, that this timer when you use 10 seconds, this timer you can use for 5 seconds. After this will be stop after 5 seconds, this will be stop after 10 seconds. Next maybe you need another sensor, you can use it here, or if you use old other sensor, it will be use this one. How many times you like to choose any this filling systems, any type of any bags, chips, bottles, juices, whatever any kind of, this command is very helpful. to making these programs, I use this command. I hope you understand about this all function. As you give the signal, it will be goes reset. How much needs to filling area, and after you like to change direction, you can use this one. I hope you understand about function. If you not understand anything, you can send me message in comment section or send me email. I will give you feedback as soon as possible. Thanks for watching. Allah Hafiz.